Hello, this is Ms. Sebuyira and welcome back to some more green chemistry. In the past, we've been talking about acids and bases, and one of the household products that we indicated fed into this category was vinegar. We were able to establish that vinegar is an acid. And so in today's lab, we want to find out exactly how much acid is in vinegar. In other words, the percent acid in vinegar. We can do this by reacting the acid with something that would neutralize it, such as a base. And in this case, we're using a 0.50 molar solution of sodium hydroxide. And then what we're going to do is that we're going to use another product that we have been using, which is an indicator. So this is red cabbage dye. And what it does is that it turns a characteristic color for an acid and a characteristic color for a base. So what you should have in front of you is a data table. And I want to show you what to fill in. In this data table, it asks you for the molarity of the base. We're using the same base throughout. So you are going to write 0.50, 0.50, 0.50. You're going to write the same number for all three trials. And then it asks you how much acid we're going to be using. In each of these flasks, we're going to be using 10 milliliters. So you should write the same number, 10.0, 10.0, and 10.0. And so I will start. I will place 10 milliliters in each of these Erlenmeyer flasks with vinegar. So we'll measure out 10. And place 10 in here, and I already filled the other two with 10 milliliters. So every single time we're using the same amount of vinegar. So I'll place this on the side. To each of the flasks, we're going to add the indicator, which is the red cabbage dye. Now, red cabbage dye has a range of shades. The reds are in the acid range, and the greens and blues are in the base range. So we are going to add a base until we neutralize this acid. And over here, you can see a pH of 7, which will mean that the acid is neutralized because an acid and a base react to form salt and water. In class, we would use something called a burette. And the burette can have a recording of the initial volume and the final volume. In your data tables, every single time, I'll be starting with 50.0 milliliters. So 50.0, 50.0, 50.0. I'll keep filling this. So we're ready to start. So this is a syringe. Right now, the reading is at 50.0 milliliters, and we're going to add to the mixture of indicator and acid until we get that characteristic green color. What you should notice is that the color darkens as the pH increases. And you can see a little bit of the green appear and then it disappears. When that color stays permanently, we can say that we have neutralized the acid. And so right now, at this pH of around 7, we have used up, the syringe reads 32.5. 32.5. So in your data table, you will record the final volume as 32.5. I'll continue with the rest of the lab. This is trial 2 completed. It started at 50 milliliters and ended up at 30 milliliters. We are now going to complete trial 3. Again, we're at 50 and we're adding until we get that permanent green color. Again, you notice the darkening as we're getting closer to the end point. The syringe reading right now, you can see, is 30. So we started at 50 and we are now at 30. So we're going to record that too. And the last thing we want to check with these solutions is what is the pH once we are done with the experiment. So we're going to use pH sticks, which will change color, and then we can read the pH on the meter. So that was solution 1, solution 2, and solution 3. It takes a while to soak in. So we have those 3, and what we'll be able to do is I will be able to match the color that the strip changes to a pH. So when you're looking on this scale right here and you try to compare what the reading is, and you can see that it's turning into a pale green, which is a pH of 7. Remember from before, a pH of 7 means neutral solution. So, summary, we took 10 milliliters of acid, added a certain amount of base to be able to come up with this final change. For the second part of class, we're going to do the calculations.